Starts. Okay, one more experiment for your laboratories: determination of ABCD parameters. ABCD parameters is nothing but a transmission line parameters. Already studied in power system 2. What is the A, what is the B, what is the C, and what is the how to calculate the ABCD parameters. The relation between ABCD parameters: V1 is equal to AV2 minus BI2, I1 is equal to CV2 minus DI2. That is nothing but V1, I1 is nothing but a sending end voltage and current. V2, I2 is nothing but a receiving end voltage and current. While evaluating the ABCD parameters, the first circuit is when I2 is equal to 0. When I2 is equal to 0 is nothing but secondary side is a open circuit. Secondary port is open circuited. Then we calculate A and C. A is equal to V1 by V2 and C is equal to I1 by V2. That is nothing but there is no units for A and C units is nothing but mho. The another one is how to calculate the B and D parameters. Then V2 is equal to 0, that means voltage is equal to 0, that means short circuited at secondary port. Whenever the secondary port is short circuited, we calculate another two parameters, one is B, another is D. B is equal to V1 by I2, that means the unit of B is nothing but ohm. D is equal to I1 by I2, there is no units for D. According to ABCD parameters, A is equal to D and AD minus BC is equal to D1. That can be also checked in our experiment. In case of symmetrical network of 2-volt parameters, the values are R1 is equal to 20 ohms, R2 is equal to 15 ohms and R3 is equal to 18 ohms. Then applying the voltage RPS is nothing but 0 to 30 volts RPS. We apply the RPS. Connection is nothing but one is the ammeter, that is nothing but I1, and another secondary port is open circuited. Then we place voltmeter 0 to 30 volts MC. We calculating ABCD parameters. We required parameters is V1, V2 and I1. V1 is nothing but applied to RPS. From the RPS we applied voltage is V1. Then V2 is nothing but secondary port of voltages. Then I1 is nothing but the current flowing to the primary circuit towards the input port. Then we are applying the 10 volts and 15 volts and 20 volts in this experiment. Then calculate the practical values. Theoretical values are calculated, do your own, depending upon the network reduction techniques or KCL or KVL, whatever may be. Which technique is do you use to calculate theoretical values? Then practical values we will send through the Google Classroom. According to your circuit diagram, this is a circuit diagram for ABCD parameters. This is a circuit diagram for ABCD parameter. For measurement of burst resistance is 20 ohms. This one is nothing but 20 ohm rheostat. The second one is nothing but 15 ohm rheostat. This is second one is 15 ohm rheostat. The third one is 18 ohm rheostat. The connections are given as this circuit diagram. From positive terminal to we give an ammeter. Positive terminal to 0 to ammeter. At the end of the 2 ohms 2 amperes, ammeter is connected to one wire is connected to the 20 ohms bottom and another is also connected to the 15 ohms bottom. And 15 ohms other end is connected to 18 ohms bottom, another is a voltmeter. 15 and other end is connected two wires. One is connected to 18 ohm rheostat at bottom terminal, another is connected to the voltmeter. At the other end of the voltmeter is connected to 18 ohms. Other end of the voltmeter is connected to the 18 ohms, 18 to 20 ohms and again to the RPS. These three are connected to the negative supply. From the voltmeter other end to the connected to the negative supply that is nothing but a black terminal, and 18 and 15 ohms of variable terminals both are joined together. 15 and 18 terminals are joined together, that can be connected to the negative of RPS. This is the connections for A and C parameters. This is connections for A and C parameter. Next go for experiment. Then switch on the supply. Applying the initially 10 volts. Then the current value is equal to 0.8. By observing here, that is nothing but 0.4 into 2. This can be connected to the 2 ampere ammeter. Then 0.4 into 2, that you get 0.8. Then voltage of V2 is equal to 5.6. By observing here, then this is connected to 30 volts. That is nothing but 5.6 is nothing but a voltage of V2. Again we change by RPS 15 volts. We change from this RPS to 15 ohms. We change this RPS 15 ohms. Then this current is 0.6 into 2 is nothing but 1.2. Then current is equal to 1.18. Here 1.18 is current, then voltage is equal to 8.2. Then voltmeter you observing, that is nothing but 8.2 volts. Again 15 volts, 20, we change this up to 20. Then ammeter reading is nothing but 0.8 to 1.58. Ammeter reading is nothing but 1.58 and voltmeter is 11 volts. Voltmeter reading is nothing but 7 volts. 11 volts. By using this tabular column, then calculate A and C theoretically as well as practically. A is equal to V1 by V2 and C is equal to I1 by V2. Then calculate theoretical and practical values, both are equal. These theoretical values are do your own, then practical values are 1.7, 1.82 and 1.81. A value and C value is equal to 1.42, 1.43 and 1.43. This is a circuit diagram for calculation of A and C parameters. Remaining two parameters B and D, here it are also again connected. Remaining circuit B and D. In case of B and D, the second port will be short circuited. The second port will be short circuited because for calculation of B and D, V2 is equal to 0. V2 is equal to 0, that means voltage is 0, that is secondary side will be short circuited. Secondary side will be short circuited. Secondary side will be short circuited. By applying the same voltages of 10 volts, 15 volts and 20 volts per second circuit, V1 is nothing but a supply voltage, I1 is nothing but ammeter in port 2, I2 is nothing but ammeter in port 1, I2 is nothing but ammeter of the short circuit current. Then from these three values we calculate B and D. B is equal to V1 by I2, D is equal to I1 by I2. Then again the connections will be same only by changing the voltmeter to the ammeter. Because of open circuit becomes short circuited, then we change the voltmeter to the ammeter. The connections will be same as that. That is nothing but positive to ammeter, ammeter other end to the 15 ohms and 20 ohms, and 15 ohm other end to 18 ohms, another one is connected to the ammeter. The three terminal is connected to the negative supply. This is a connection from the positive to ammeter, ammeter to the 20 ohms and 15 ohms are bottom terminals, 15 ohms and 20 ohms are bottom terminals, 15 ohms and 20 ohms bottom terminals. Again this is and 15 other end to the 118 ohms and 20 ohms, 15 other end to two connections, one is 18 ohms and other one is nothing but a ammeter, other one is ammeter to 18 ohms, ammeter to connected to the negative supply and 18 ohms to 20 ohms, variable 18 ohms and 20 ohms both are connected to this one and 20 amperes is connected to the negative of the supply. This is the connections for secondary circuit, this is connections for secondary circuit. Then again to switch on this RPS by applying the 10 volts, by applying this 10 volts, then ammeter note down the I1, I2, this is I1, this is I2. I1 is nothing but the I1 value is equal to 1.16, that is nothing but 0.7 into 2, then we get 1.16 and I2 is equal to 0.7, I2 is equal to 0.7. Similarly, by changing the 10 to 15 and 10 to 15, 15 to 20, then we get these values. At 10 volts, we get I1 is equal to 1.16, I2 is equal to 0.7. Per 15 volts, I1 is equal to 1.5, I2 is equal to 0.9. At 20 volts, I1 is equal to 1.76, I2 is equal to 1.02. Then from these three values, we calculate the B. B is defined as V1 by I2, that is like V1 by I2. V1 is not the RPS, I2 is equal to 0.7, then got 14.28. Similarly, for 15 volts, 14.47 and 20 volts, 14.20. Similarly, calculated D, I1 by I2, then I1 value and I2 value both are measured in this experiment, then I1 by I2, then gives the D values. By observing these two, A is approximately equal to D and AD minus BC is equal to 1. Then that can be proved in this experiment. Theoretical values you can done and practical values we will give through the Google Classroom. Okay, this is another experiment for you, that is nothing but ABCD parameters. Finally, conclusion is nothing but transmission line parameters are determined theoretically as well as practically. Okay, thank you, Amma.